You may know the children's nursery rhyme, "Twinkle, twinkle, little star, how I wonder what you are." You may have also looked up at the night sky and wondered why the stars seem to twinkle. But despite knowing this nursery rhyme, you may not know why the stars seem to flicker in the night sky. So why is it that stars seem to twinkle? So when you look up at the night sky, you'll see that stars appear as really small bright spots of light in the night sky. Now in reality, stars are really massive, but because they're so far away from us, this is why they appear really small. The moon, on the other hand, is much smaller than a star. Because it's so much closer to the stars in the universe to us, it appears really big in the night sky. You may have also noticed that stars seem to flicker slightly and they change in their brightness or moving very slightly in the night sky. This is what we mean when we refer to stars twinkling. And the scientific name for this process is something called scintillation. So if we see stars in the night sky constantly change in brightness, is this because stars fundamentally change brightness over time? Well, stars are just the same as our sun, they're giant balls of burning gas in space. It's true that stars burn a different amount of gas each second. However, this difference in the amount of gas they burn is really small. Not enough to be able to change the brightness that we're able to see with the naked eye. So if it's not the star changing brightness, then what causes stars to twinkle? Well, it's all down to the Earth's atmosphere and how light from stars passes through it. You see, light happily travels through a vacuum or through a single material like air or glass. It just travels straight through. However, when light passes between two materials such as air and glass, it can change direction, and this is something called refraction. Now an example of this is when light travels through a window. As light passes through the air outside your house, through a window of your house and into the air inside, it can change direction. And this is all due to the fact that light travels at different speeds in different materials. You can try this for yourself at home if you have a glass block and you fire a laser through it, such as a laser pointer. What you notice is as the laser hits the surface of the glass, it changes direction slightly as it changes its speed. And this happens for all light, not just lasers, it's much harder to see. However, there are lots of examples on how this can affect you in real life. One example, for instance, is if you try to grab a rock at the bottom of a river. You might notice it's a little bit difficult because it's kind of hard to try and find where the rock is. And this is because as the light hits the surface of the water, it changes direction. And this makes the rock appear in a different place to our eyes than it actually is in reality in the river, making it much harder to try and pick up the rock. So what does this have to do with stars twinkling? Our atmosphere doesn't contain any glass and it doesn't contain different materials. There's only one material in our atmosphere, and that's air. Well, it's all down to the motion of particles within our atmosphere. As all the particles are whizzing around, sometimes it can create slightly more dense or slightly less dense pockets of air in our atmosphere. And because they all have different densities, these small pockets of air, they act like different materials. This means as light rays from background stars pass through these small pockets, it acts just like passing between air and glass in our previous example. And this causes the light to slightly change its speed and hence slightly change its direction as it passes through these small pockets of air. And this is what causes the light to be refracted and stars appear to twinkle. Don't believe me? Well, there's a really simple proof of this, and all you need to do is look at stars straight up above your head and stars near the horizon. You see, the stars near the horizon, the light from these has to go through more of the Earth's atmosphere than the stars straight above your head. Now, because they have to go through more of the atmosphere, they go through more of the air turbulence, these little pockets of different density air, which means the stars near the horizon appear to twinkle more than the stars directly above your head. This is a nice little proof that this is the reason why stars twinkle. You can try this at home for yourself, and all you need is a laser pointer and some steaming water. As the steam rises upwards, it creates small dense pockets of steam, denser than the air around it. So as you fire a laser through it, it changes direction and speed as it passes between pockets of air and pockets of steam. And this will make the laser look like it's twinkling, just like stars do. Just remember, if you're going to do this at home, be careful because boiling hot water and lasers can be a bit dangerous. So now we know why stars twinkle. It's all due to pockets of air of different density in the Earth's atmosphere. But do other objects in the night sky twinkle? Well, if you get outside tonight and you look up at a planet, you'll notice the planet doesn't seem to twinkle. This is all due to how far away the planets are compared to the stars. Because the stars are really far away, they appear as really small points of light in the night sky, almost a single point of light. Whereas the planets are much closer, so actually they appear much bigger in the night sky than they do to stars. Now what this means is, if all the light from the stars is coming down in a single point to us, if it goes through a small pocket of different density air in the atmosphere, all the light from the star will change direction and will appear to twinkle, and so the whole star itself seems to twinkle, so it has a really big effect. However, because the planet is much bigger in the night sky, if some of the light goes through one of these pockets different density, the rest of the light can come straight to us, and so the effect of making it look like it's twinkle is much less for planets than it is for stars. So this is why stars seem to really twinkle, change brightness and move in the night sky, whereas much closer and larger objects such as planets and the moon for example don't seem to twinkle. So stars seem to twinkle due to pockets of different density air in the Earth's atmosphere. It's not due to the stars changing their brightness, and planets don't seem to twinkle because they're much larger in the night sky. So next time you say the nursery rhyme "Twinkle Twinkle Little Star," you'll know exactly what they are. Thank you very much for watching. Don't forget to check out the rest of my channel for some really good science videos. You can also like and subscribe to this video and leave some comments below. Check me out on Twitter at UKAstroNut. Otherwise, thank you very much for watching everyone, and I'll see you all soon. There's something special about seeing a solar eclipse. Many of us will only get to see one during our lifetime because they're that rare an event. Solar filters on cameras and solar eclipse glasses means that millions of us can get together and enjoy this spectacular event together. But what is a solar eclipse? What causes it? And what science can we do with one?